So we are going to proceed to oblong method. For this, what do we require is a rectangle. The rectangle, something of the say this is a rectangle. My ellipse will be inscribed in this. Now what is this? This is the length of the major axis and this is the length of the minor axis. So what I am basically doing is that I am drawing a rectangle whose smaller side is equal to the minor axis and the longer side is equal to the major axis. So first of all I am going to draw a rectangle. So let's start. Now I am going to draw a rectangle of PQRS with following dimensions. My height will be PS or RQ, that will be my length of the minor axis, and my width will be PQ and RS, that is the length of my major axis. Let's start. So I have this rectangle P, Q, R and S, where PQ and RS is the length of the major axis and PS and RQ or QR is the length of the minor axis. So now what I am going to do is, I have this rectangle with me. I will mark the midpoints of the upper side and the lower side and I will join them. So I will have the minor axis and I will join the midpoints of the left hand side and the right hand side to get what? To get my major axis. Let's look at the figure. Now I will take midpoint of PS and QR and join them. If I join them, I will get my major axis, something like this. This is the midpoint A of PS and this is the midpoint B of QR. So I have joined it to get what? This is my major axis. Now for my minor axis, I will take midpoint of PQ and midpoint of RS and join them. For if I join both of them, the midpoint, I will have my minor axis CD, and of course I am going to mark the midpoint as O, as I always do. Okay. Now what we are going to do is, we are going to divide these sides. First we are going to just consider the upper portion, then we will go to the lower portion. So AP and AO into equal parts and OB and BQ into equal parts. To be specific, we will be dividing it into 7 equal parts. OA into 7 equal parts, OB into 7 equal parts, AP into 7 equal parts and BQ into 7 equal parts. Now you should note, we are doing this for the upper side of the rectangle. Then if we repeat the this procedure for the bottom side of the or the lower half of the rectangle, we will have the points which are there on the ellipse on the lower part. So we will start. First I will divide OA into 7 equal parts, that is 1, 2, 3 and 4, 5 and 6 and 7. As you can see, it appeared. And then I will divide OB into 7 equal parts, that is 1, 2, 3, 4, 5, 6 and 7. Then I will divide PA into 7 equal parts, that is 1, 2, 3, 4, 5, 6 and 7, as you can see, as they are appearing on your screen. Then I am dividing QB into 7 equal parts, that is 1, 2, 3, 4, 5, 6 and 7. So I have these points. Now what next time am I going to do? I am going to join point 1, point 2, point 3, point 4, point 5, point 6 and point 7 to C on either side of the minor axis. From C I will draw a line to 1, then 2, then 3, then 4, then 5 and then 6 and then 7. Then I am going to do the similar thing on the right hand side. 1, 2, 3, 4, 5, 6 and 7. Okay. So now I have these reference lines, that is C1, C2, C3, C4, C5, C6, C7 on both the sides of my minor axis. Now what I am going to do is, next I am going to do similar thing from D to the horizontal line which is there on the major axis. I am going to join D to 1 and then extend it to meet C1. You can see. Now I have taken this point because this point will be there on the ellipse, so I marked it as red. Now D to 1 and then extend it to meet C1. D to 2 extend it to meet C2. D to 3 then extend it to meet C3. This is how we are going to do. Mark that point as P1. Then D to 2 extended to meet C2, P2. D to 3 extended to meet C3, P3. Then D to 4 extended to C4, then P4. Then D to 5 then extended to C5, that is P5. Similarly we have P6. Now the same thing we are going to do on the right hand side. So I have this P1 dash, P2 dash, P3 dash, P4 dash, P5 dash, P6 dash and P7 dash. Repeating the same procedure that I did. So sorry, I divide this A and S into 7 equal parts, B and R into equal parts. 7 equal parts. Now these parts will be joined by D through the lines, just as we did from C to 1, and then through C we are going to pass lines that we did actually through D. So I'll have what? I'll have my, say, one by one, you'll see you'll have these points, and then you'll have the points on the other side of the minor axis. So this is what we have. Now these are all the points on the ellipse. Now what we are going to do, the same thing that we do, we will join all the points starting with in clockwise direction to C, to P1, to P1 dash, to P2 dash, P3 dash, and this way, and then we'll finally again going to reach to C. So we have the required ellipse by the oblong method. I hope you understood. Very simple. These methods are very simple. You just have to plot the points on ellipse. Once you have the points on ellipse, you have to join all the points to get what? To get the required ellipse. The final method that we are going to discuss is the directrix focus method. Now this method should be understood very closely. It is also very easy, but I have taken it at the last because it has a few glitches. Now we will discuss a few things before starting this method. The first is, it is based on first definition of ellipse, in which we are going to, in this method, eccentricity will come into play. Before that, eccentricity was not coming into play. Now here I will tell you what the directrix is. Yes, so this is my focus, and this is a line that has been drawn. Now this line would be directrix only if, say, if I have marked these 1, 2, 3 and 4 lines. Okay, now I'll first take the distance of this line and then divide it by the distance of this line, and then the ratio will be equal to, say, E1, and then this, I'll take this line and then divide it by the connecting line, and then I'll take the ratio, say, E2. Then the ratio will come to E3 and the ratio will come to E4. If all these are equal, that is E1 is equal to E2 is equal to E3 is equal to E4 is equal to E, then this line will be known as my directrix. So if I say what is the basic definition of directrix, then I'll say the directrix of a conic section is a line which, together with the point known as focus, serves to define a conic section. That is basically an ellipse. For this particular section, for parabola there will be also a directrix, for hyperbola there also will be a directrix. In this directrix focus method, we are just concentrating on ellipse. So that is the thing. Okay, moving ahead, for discussion of this method, what we are going to do is we are going to make two assumptions. Say this might be taken as an example. So I'll take the focus as 70 mm away from the directrix, and my eccentricity is 3 by 4. Okay, so what is my first step? The first step is to draw the directrix and to draw the axis, that is CC dash. There is no particular measurements for it. It is just that AB should be perpendicular to CC dash, or after drawing AB, when you are drawing CC dash should be exactly perpendicular to AB. So first is I'm drawing AB like this, and then I'm going to draw CC dash, which is exactly perpendicular to AB. So this will be the line on which the major axis will be there, and minor axis will be parallel to AB. So this is the axis which is passing through the center of the ellipse. Now we know that focus is at a distance of 70 mm away from the directrix on CC dash, because that is the axis. So now let's see, I'm going to mark F, that is at a 70 mm distance from this directrix, that is from point C. So CF is 70 mm. Okay, the next thing, now we have CF. So we are going to divide it into 7 equal parts. Now why I have taken 7 is depends on my eccentricity ratio. See, my eccentricity ratio is 3 by 4. So I'll add these two, that is 3 plus 4, that is 7. So I'm going to divide it into 7 parts. If I add some other thing, say 2 by 3, I'll divide it into 5 parts. Why 5 parts? So that I am able to make out on what is my end point, one of the end points that is there on the side of the directrix. So on the fourth division, I'll mark V. Let's mark it first, and then I'll tell you why this V is being marked on the fourth division. Okay, so I'm going to divide it into 7 equal parts. 0, 1, 2, 3, 4, 5 and 6 and 7, finally 7. Okay, now I marked V on the fourth part, as I said. Now what is the thing is that my eccentricity ratio is 3/4. So my that is this point, the point on through which the ellipse will pass on this axis, will be 3 points away from F and 4 points away from C. So from C, 4 points away, I have marked this point V. So this point V will be one of the points that is the end point of the ellipse. That is one of the points on the extreme left hand side of the ellipse on your screen. So I have marked this. So next step, I hope you understood why I have marked point V 4 clicks away from C and 3 clicks away from F. Now step number 4. At V, we will erect a perpendicular. Now that perpendicular will be equal to, I'll mark the endpoint as B dash, and the distance will be equal to V to F, that is initial point of the ellipse and the focus. Something like this. See, this is V to F. Distance is equal to this. I'll erect a perpendicular at V and mark it as B dash. Understood? Now my next step, I'm going to draw a straight line passing through C and B dash. This is a straight line passing through C and B dash. So I'm going to draw a straight line and extend it till my paper. Now why I have drawn this, you'll be able to understand in the next step. Now with Fs center, I'm going to draw a line which is at 45 degrees with CC dash. Now why I'm doing this, to get my V dash point. How I'm going to get the V dash? See, once I have drawn the 45 degree angle, it will intersect this CB dash at a particular point, and I'll mark that point as D. From D, I'll drop a perpendicular downwards on CC dash, and that point where it intersects on CC dash will be V dash, will be my other right hand side extreme point of my ellipse. See, with Fs from F at angle of 45 degrees, I'll draw a line which intersects at D, for CB at D, and then I'll drop a perpendicular which is at V dash. Now this V and V dash is between what the ellipse will be created. Now we want some points above and below so that we can construct the ellipse. We have both the endpoints, so we are going to construct the ellipse. Now what we are going to do is, we are going to divide, we are going to take a few midpoint of V and V dash, that is the center of, we are going to find the center of the ellipse, and then we are going to erect a perpendicular through that ellipse. See, this O dash, and this is the perpendicular. This is the midpoint of V dash, and this is also the midpoint of the ellipse, and V dash is the major axis. Remember, V dash is the major axis, and on this perpendicular line we will have the minor axis. Now what we are going to do is, we are going to take a few more divisions in this part, say 8, 9 and 10. 3 more divisions I'll take randomly. I'll take a point here 8, then I'll take 9, and I'll take randomly I'll take 10. Now my next step is, through all these points, that is 5, 6, 8, 9 and 10, I am going to draw perpendiculars like this, through 5, then 6, then 8, then 9 and then 10. And where these points are getting intersected on C, D, I'll mark this as 5 dash, 6 dash, 8 dash, 9 dash and 10 dash, and this point will be O dash. Now why these is important? Because I need this distance 5 dash, 6 dash. This distance will be important to me. See, 5 dash, 6 dash, 8 dash, O dash, 9 dash, 10 dash. These distances will be important to me in the next step that I'm going to do. What I'm going to do is, I'm going to take radius as 5 dash. This is my first step. I'll take radius as 5 dash, put my center at F, cut an arc on the same line 5 dash above and below the major axis, and then I'm going to repeat the same procedure for 6, 0.6, 0.8, 0.0, 0.9 and 0.10. See, with radius is equal to 5 dash and center is equal to F, I'll cut arc on this line above and below. I'm going to mark points, because if I mark arcs it won't be visible on the screen, and mark this as P and P dash. Now I'm going to do similar thing. I'm going to take radius as 6 dash, 6 dash, center as F, and cut arcs here and here on this line, and mark this as P1 and P1 dash. Perfecto. Then next for 8, radius will be 8 dash, center as F, and cut arcs here and here at P2 and P2 dash, then P3 and P3 dash for O dash, then 9 for 9, for 10, I have done this. Now I have my different points on the ellipse. Now again the same old story I am going to repeat. Now we also know that these are the endpoints, so these will also be there on the circle, and when I join these points clockwise, I have my ellipse through the directrix focus method. So today we have discussed what all things have we discussed. First we'll discuss classification of engineering curves, what types of engineering curves are there. Then we came to conics. Then we discussed what type of curves are created in conics. Then we started with construction of ellipse. Then first we discussed arc of circle method, then we discussed concentric circle method, then we discussed the oblong method, thereafter we discussed the directrix focus method. So what next? So this session will come to an end today, and the slide shows you what is in store for you next Sunday, same time, 12 to 1, that is our trademark time, we are not going to change that. For conics, conics will be continued next Sunday, in which we'll be discussing parabola and hyperbola, construction of different, and then we're going to start with cycloidal curves if time is left, because there are different methods for construction of parabola and different methods for construction of hyperbola, and that will be next Sunday, 7th October, 12 noon sharp. Now as always, I give you a quote at the end. This is what I love to do, and discuss a little bit of philosophy, so that there is some inspiration that has been generated. You might know Henry Ford. Henry Ford is an English writer. Now he says, whether you think you can or you think you can't, in both the conditions you are right. So it is basically saying that if you think you can, you will be able to do it, and if you think you can't, you won't be able to do it. So that is what Henry Ford has said, and I believe that we always should think if we can. There is no condition that is impossible if you try. So begin trying before accepting your defeat. Try, and then if you get defeated, there is no regret. Okay, I got defeated, but I tried. So that is the main thing that you have to do. And if you have any query,